For centuries, fictional depictions of planets orbiting other stars have fired our imagination, from the desert world of Arrakis in Dune to the lush jungles of Yoda's planet Dagobah in Star Wars. We humans have been fascinated with the idea of exotic, far-off worlds. We now know that worlds beyond our solar system, known as exoplanets, do exist. In fact, there are a whole lot of them. An international team of researchers has used NASA's James Webb Space Telescope to measure the temperature of the rocky exoplanet TRAPPIST-1b. TRAPPIST-1b is the innermost of 7 known planets in the TRAPPIST-1 system. Orbits its star at a distance of 0.011 AU, completing one circuit in just 1.51 Earth days. This planet receives about 4 times the amount of energy that Earth gets from the Sun. Although it is not within the system's habitable zone, observations of the planet can provide important information about its sibling planets as well as those of other M-dwarfed systems. TRAPPIST-1b is slightly larger than Earth, but has around the same density, which indicates that it must have a rocky composition. Webb's measurement of mid-infrared light given off by TRAPPIST-1b suggests that planet does not have any substantial atmosphere. The star TRAPPIST-1 is an ultra-cool red dwarf with a temperature of only 2566 kelvins and a mass just 0.09 times the mass of the Sun. The recent measurement is based on the planet's thermal emission, heat energy given off in the form of infrared light detected by Webb's mid-infrared instrument. The result indicates that the planet's dayside has a temperature of about 500 kelvins, roughly 450 degrees Fahrenheit, and suggests that it has no significant atmosphere. The key was in the light curve produced as the exoplanet orbits the star. When an orbiting exoplanet passes between us and the star, the exoplanet blocks some of the star's light, causing it to dim a little. But when the exoplanet passes behind the star, an event known as a secondary eclipse, dimming can also be observed. This is because when the exoplanet is on either side of the star, it reflects some of the star's light, in addition to emitting any radiation of its own, increasing the overall light observable from the system. That means any light observed during the secondary eclipse is emitted by the star alone. By extracting the additional light that can be detected when the exoplanet is off to either side as well as the estimated reflected starlight, scientists can determine how much infrared radiation is emitted by the exoplanet itself, thus taking its temperature, and this in turn can reveal the presence or absence of an atmosphere. This is the first detection of any form of light emitted by an exoplanet as small and as cool as the rocky planets in our own solar system. The result marks an important step in determining whether planets orbiting small active stars like TRAPPIST-1 can sustain atmospheres needed to support life. It also bodes well for Webb's ability to characterize temperate, Earth-sized exoplanet using MIRI. If we want to understand habitability around M stars, the TRAPPIST-1 system is a great laboratory. These are the best targets we have for looking at the atmosphere of rocky planets and a truly tantalizing target in the search for life outside the solar system. The discovery of the TRAPPIST-1 system was reported in 2017. 7 rocky exoplanets orbiting a red M-dwarf star 40 light-years away. 3 of those exoplanets are within the star's so-called habitable zone at a distance from the star that's not so close that all liquid water would boil off, nor so far that it would freeze. The worlds around it are much closer to the star than our home system, with the most distant on an orbit of just 18.8 days. Since red dwarf stars are much smaller, dimmer and cooler than the Sun, this means that the habitable zone sits much closer to the star. But red dwarf stars are much more violent than the Sun, lashing the space around them with powerful flares. Future work, the researchers say, could further characterize the global heat distribution of TRAPPIST-1B in order to better understand rocky planets orbiting red dwarf stars and how these systems differ from our own. The James Webb Space Telescope is the world's premier space science observatory. Webb will solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of our universe and our place in it.